Okay, just for fun, I thought I would work the 9.1 classwork that we had. Um, I didn't end up taking this for a grade. This was just more notes to have in class, and it was really just to talk about what we learned from the video in 9.1. And for those of you who may have been absent, I'm sorry you weren't there for the conversation. So if you've received this document but haven't completed it, or just want to look at it again and talk about it again, that's just what I'm going to do in this video. All right. Again, this wasn't for a grade, but I'm just going to go through it kind of like what we did in class and just work through it. Okay. So this unit or this lesson was on operations with rational expressions. And the operations we're talking about are plus, minus, divide, and multiply. Yeah, the four basic operations. Now, I have the rules written up here at the top of the worksheet. Multiplying two rational expressions, that's the rule. When you do dividing, it's this. It's division is keep, change, flip, right? You keep the first fraction, you change it from division to multiplication, and then you take the reciprocal of the second fraction, and that's how you can divide two fractions. Okay. Adding and subtracting, you kind of have to get a common denominator so that you can add them together. Okay, so the first thing we started with in class was a quick homework check-in to see how you did with these problems. And if you're doing this from home and you want to give yourself some time, I think I gave everybody about 8 minutes to do these two problems. So if you'd like, if you want to pretend like you're in class right now, pause the video, give yourself 8 minutes, and try those two problems. Okay, so assuming you either paused the video or didn't pause the video, I'm just gonna go through them. Okay, this is still the opportunity to pause if you would like to give it a try on your own. All right. So the first thing we need to do, I guess it doesn't really matter when you do this, as long as you at some point do it, is to factor. Now, with this first question, I do notice that we can do keep, change, flip real quick. So I'm going to zoom in here, okay? See, it's a division, right? I'm doing a rational expression divided by another rational expression. So I'll do keep, change, flip. I'll say x squared minus 2xy plus y squared over x plus y times, and I'm going to flip the other fraction and take the reciprocal of the other fraction, okay? And that's how you can get started with that one. And now it's a matter of factoring. So we want to factor everything that we can. So both all the numerators and all the denominators. So I'm going to look at the first expression in the numerator right here. That is a difference of, I'm sorry, I misspoke. That is a perfect square trinomial, which is x minus y squared. This is a factoring pattern that we've talked about and one that you need to recognize. It's not always easy to recognize, but it's certainly one you have to know. So if you need to brush up on your difference of, I'm sorry, I keep misspeaking. I want to say difference of squares, but if you keep messing up on your perfect square trinomials, go back, study those some more, okay? Now what I'm trying to say is this one. That's a perfect, oh my God, I cannot speak. I almost called that one a perfect square trinomial. I am all over the place. This numerator is a difference of squares. Slow down, Mr. Spake. I'm so excited. I just want to tell you everything. X squared minus y squared factors is x plus y, x minus y, by the difference of squares identity. Okay? And the denominator is x plus y times x minus y. So notice naturally these cancel, and I'm left with x minus y quantity squared. And that's my answer. Done. Okay? All right. Sorry for being all gibberish there. Okay, for the next question, in order to add these two rational expressions, I need a common denominator. Now, x plus y You need to view that as a single term, as a single expression. Similarly, you need to view x minus y as a single expression, okay? You can't think, oh, well, they both have x's, so one just needs a positive y and the other just needs a negative y. No, you can't do that, okay? You have to view that as a single expression being added together. So the way I do this is I take x over x plus y times x minus y over x minus y. I'm talking like the Khan Academy guy. Y over x minus y times x plus y over x plus y. Isn't that how he kind of talks? I don't know. Sorry, Khan Academy guy. You're great. You have fantastic videos, probably better than mine, but he talks a certain way, distinct. Okay, so notice what I'm doing here is I've got an LCD here, x plus y, x times y minus y. And in the numerator, I'm just kind of putting these things together, right? This is x times x minus y plus y times x plus y, okay. And so then if I distribute this, I get x squared minus xy plus xy plus y squared over x plus y, x minus y. And those middle terms, negative xy and positive xy, those cancel. So this just ends up being x squared plus y squared over, and I don't know, if you want to, that's the difference of squares, which you could expand as x squared minus y squared. By the way, you don't have to expand that, though, okay? I might even write this. You do not need to expand the denominator. I just want to let you know that, okay? You don't need to do that. I'm not requiring that, okay? I just did that because it looks kind of pretty. It looks kind of pretty with x squared and y squared all on top and all that. By the way, you might be thinking, Mr. Spank, doesn't x squared cancel out with x squared? And so that is just y squared over negative y squared. Those cancel, and then I'm left with positive 1 over negative 1, so the answer is negative 1? No, wrong. Sorry, don't do that. The only time you can cancel is when everything is factored and you have common factors on top and bottom, okay? Those aren't factored. That's not, the x squared plus y squared is irreducible, and so that is as factored as it's going to be, so we have to put parentheses around that, okay? Don't be canceling business. In fact, that is what the next section is for. So the next section is error analysis. Each of these students made a classic blunder, just a frequent mistake that students make while they're studying algebra. So this part of class, I think I gave another 8 minutes to find every mistake and circle it, and just give a quick explanation for why that mistake is wrong. And some of these students made more than one mistake, so find all mistakes. So if you want to pause the video, give yourself 8 minutes and try to find all the mistakes, you are welcome to, but I'm just going to move on and go. Okay, so Bill's blunder. Oh, Bill. Well, I noticed instead, okay, so he's given the problem in step 1, and then in step 2, he crosses out x squared on top and bottom. So immediately, that's a mistake right there, okay? Bill, you can't do that. And that's exactly what I was just talking about with that last example. Cannot cancel terms like this. I was trying to think of a nice way to say it, but you just can't, all right? It doesn't work. That's not how we do fractions. Look, here is the fraction 2 plus 3 over 2 plus 5. Now you know that 2 plus 3 is 5, and 2 plus 5 is 7. So I know that this comes out to 5/7. But if you use this rule of canceling out common, I don't know, terms on top and bottom, and you said, oh, well, 2 and 2 divides, so then it's just 3 over 5. Except that's erroneous, right? That's false. Never. No. We can't do that. And that's a really common mistake for algebra students to make. So be very careful with that, okay? The only time you're going to cancel is when you've completely factored everything and you have common factors on top and bottom. Now, the next mistake, if you're following along, assuming he made this mistake, he's okay here. And he's even okay here because right there he's trying to get a common denominator, and that's good. But then he makes a mistake right here. Okay? And you know what? I'm going to make that a nice circle again. Pretty circle. Nice oval. And here it looks like he forgot the negative. Forgot the negative. And if you're saying, what? What do you mean? This negative sign needs to distribute to these terms. So that should be negative x plus 2. Okay? He just, oops, forgot it, and didn't write that there. So it wasn't there. Okay. Let's go on to Phil. Phil's blunder. So he's starting off with this problem. He's getting a common denominator correctly. But then Phil, he just makes some weird mistakes here. First of all, he's going to need to distribute this negative 4 to both x and negative 3, which he does not do here. So that should be plus 12. Okay, that's the first mistake. And the second mistake is, what the heck? We say W2H heck. What the heck? What did he do here? Right? X minus 1, it was x plus 5. What are you doing? Phil, my guy. So he made 2 mistakes there. I don't know why he wrote x minus 1 there, but that's just silly. That's just silly what he did. Okay. And then he does make another mistake here. Oh, there's my oval. Okay. He makes a mistake here because he crosses out terms again on top and bottom. Can't cancel like this. You can't do it, Phil. Right? You kind of have to consider x squared plus x minus 3 as a single term. That is a factor. Okay? That's the thing. You would need x squared plus x minus 3 on bottom to cancel this. You got to consider that x minus 3 is a different term from x squared plus x minus 3. Okay? So you can't cancel those. Those aren't factored like that. On to Jill. I'm sorry I'm yawning. It's been a long day. Oh, Jill's blunder. Well, Jill. Jill. A lot of you are going to make this mistake because I notice this mistake all the time. And it's a silly mistake, and it's just a tiny mistake you have to watch out for, okay? So Jill says, okay, it's x minus 7, so I need an x minus 1 on top and bottom here. So that's good. Needs an x minus 7 here, so that's fantastic. Wonderful job, Jill, getting a common denominator. But then she cancels out the x minus 1 and the x minus 7. Jill, what are you doing? Right? What are you doing, Jill? So the reason I'm saying I'm being all, what are you doing, Jill? Is because Jill just multiplied by x minus 1 over x minus 1 in order to get a common denominator, right? That's the step she took. She put this here, and then she just took it away. She just undid what she did. And that's just silly, Jill. That's just silly. But I will say, it's not necessarily wrong. It's just like huh? Right? It's just like, what? What are you doing here? The real mistake, however, is in this line. We can't add fractions this way. Can't add fractions like this. And that's because no common denominator. Okay? And you might be saying, Mr. Spade, this seems like a silly example, except I'd say maybe 20% of my students last year being 2022 in the spring, were making this exact mistake. So you want to be very careful that you don't make this mistake, okay? It's kind of just backwards. It's like going in a loop, right? You took one step forward, and then you canceled it, so you took one step backwards. And then by taking that step backwards, your brain, you thought, hey, I got my common denominator and I just canceled like terms, so now I can add them together. Well, you don't have a common denominator anymore. You see, the problem is Jill's back at square one, and then she skips to this step and just adds them like this. Well, we can't add fractions like that. So be careful, okay? It's a very particular line of reasoning. It's like you think you did the step to get the common denominator, you simplified because you know that's what you're supposed to do, and then because getting the common denominator was a previous step, your brain thought you had the go-ahead to go ahead and add these things, but by canceling it out, you don't have a common denominator anymore, and so you're making a mistake. Okay, hopefully that explanation helps and you like that. All right. Last part of this video was finding a common denominator versus finding a least common denominator. And for video purposes, I'm not really going to make you do this. Okay, this was a class kind of thing that I really just wanted students to feel. And honestly, I don't care that you feel this right now as you watch the video. Okay, so to give you some context of what I did in class, we talked about finding a common denominator versus finding the least common denominator. And so I bothered with having this method 1 section where it is just finding a common denominator. Now, to find a common denominator, really all you have to do is multiply by every other denominator and then add them together. That way they have a common denominator. So just to illustrate, it's kind of like taking 10/3 and multiplying by 4 over 4 and 6 over 6. That way your common denominator is 3 times 4 times 6, right? And then if you do 11 over 4 times 3 over 3 times 6 over 6, you again get this 3/4/6 thing. And then if you do 7 over 6 times 3 over 3 and 4 over 4, you get the 6 times 3 times 4. And the thing is, this isn't an efficient way to do the problem. And I made you do this in class just because it's kind of excruciating and not fun and stupid. It's like, why would I do it this way when I totally know of a better way to add this stuff, right? Which is finding a least common denominator. But the reason I did this is because while you may understand how to find an LCD with normal fractions, example being, if you look at 3, 4, and 6, I'm hoping you already know that the LCD is 12. Just by looking at it, you say, I know that the common denominator has to be 12 because 12 is the smallest number divisible by 3, 4, and 6, right? It just is. And that's because you have good numerical intuition. You have a good understanding of the number 12 because you know its factors. You know that 12 has factors 1, 2, 3, 4, 6, and itself, right? You know that. But the thing is, you don't know polynomials as well as you know basic numbers like this, okay? And so I'm going to go through how to find the least common denominator with those numbers, just like you would in, I don't know when they teach this, maybe 6th grade, I want to say. I don't know when you add fractions together. But let's find the least common denominator. So I need to do 10 thirds minus 11 fourths plus 7 sixths. And I'm going to do this the way they do it in middle school, okay? Or elementary, depending on when you learn this. To find your least common denominator, and this is true for how we're going to do it in algebra, you have to factor every denominator. So I'm going to look at 10 over 3 is prime, so 3 is fully factored, minus 11 over 4 is 2 times 2. And then 6, its prime factorization is 2 times 3. So now I ask myself, what is the least common denominator, LCD? Well, to identify the least common denominator, you just want every factor necessary, yeah? So observe. I know I need a factor of 3 because 3 is in my denominator for 10 thirds. So the least common denominator has to have a factor of 3. Now I'll move to the next fraction. It looks like it needs 2 2's. There's 2 of them, right? There's 2 2's. 2 times 2. So my least common denominator, well, it needs a 4, but I'm going to leave it as its factorization, 2 times 2. And the reason I'm leaving this factorization is because when I go to the last one here, I already have a 2 in this LCD. And I already have a 3 in this LCD. So my least common denominator, its factorization, already contains the factors 2 and 3. You see, because 2 times 3 is 6, so this 6 is already hidden within the LCD. I don't need to put another 2 and 3 in here because I've already got it as factors, okay? And so now that I've got 3 times 2 times 2, that's my 12. And so then I have to multiply each fraction such that the denominator becomes the least common denominator. So you see, if I do 10 over 3, I got to multiply that by the other factors, 2 and 2, which is we know is 4. Because the idea is I need to make 3 12. So I multiply 3 times 4, which is really just 2 times 2 is the other factors, minus 11 over 4 times, well, how do I make 4 become the LCD 12? I got to multiply by 3 over 3. And then how do I make 6 become 12? I got to multiply by 2 over 2. Doing all of this, I think the final answer is 7/4, but I'm not going to bother with that calculation because that's not really the point of the video, okay? The point of the video, whoa, look at this shape I'm making here. It's kind of neat. The point of the video is to show you how to do LCD. Now look, this process we just did is no different algebraically. None. It's the exact same process. So you need to have a strong understanding of how to do it with numbers. That way you can do it with algebra. So I'm going to move on to number 2 here. And by the way, I'm not going to bother with method 1. Method 2. Well, I said you need to factor your denominators. So we're going to take x over x squared plus x minus 6 plus 3 over x squared plus 4x plus 3. And you want to factor your denominators. This is x over, the first one factors is x plus 3x minus 2. And the other denominator factors as x plus 3 times x plus 1. So my least common denominator is just every denominator I need. Well, I need a factor of x plus 3. So I say a factor of x plus 3. I need a factor of x minus 2. And now this x plus 3, if I move to the next denominator, all right, my LCD already has this, right? Because it has x plus 3 as a factor. So it doesn't need it again. It already contains that factor, but it does need x plus 1 because that's not currently present. So I've built my least common denominator, and now I just need to multiply every fraction in such a way that the LCD becomes that, or that every denominator becomes the LCD, I should say. So now look, you could multiply each individual fraction, but I'm going to tell you this. You know the LCD, so just draw a big fraction bar, okay? You know that the LCD is x plus 3 times x minus 2 times x plus 1, okay? Save yourself the trouble of writing a ton of fractions. Just make it one fraction. Now, if I'm looking at this denominator, I've got my x plus 3, I've got my x minus 2, but I need an x plus 1. So I'm going to multiply by x plus 1 on top and bottom. Now doing this makes it match this LCD, but basically what I need in the numerator is this x times x plus 1. So that's what I'm going to write here, x times x plus 1. Plus, and then the same idea over here, I have x plus 3 as a factor, I have x plus 1 as a factor, but I don't have x minus 2, so x minus 2 is what I'm going to be putting on top and bottom. So it's plus 3 times x minus 2. Now I'll just use some basic distribution here, x squared plus 3x minus 6 over x plus 3, x minus 2, x plus 1, and that's x squared plus 4x minus 6. And you do want to check that that quadratic is factorable. Negative 6. Here's my 4. What two numbers multiply to get negative 6 and add to get 4? Nothing. So not factorable. So that means my quadratic in the numerator is irreducible, and therefore I am done. Because there's no common factors on top and bottom to simplify. Whew. And there it is. That is how you identify a least common denominator. You essentially just look, factor every denominator, and then list every factor you need such that every denominator has its factor in the LCD. Okay? And there you go. Now, the thing about method 1 with number 2 here is, well, it gets way too complicated. I'm going to say way too complicated. Because if you try to find the LCD here, well, it just gets messy. Because you're basically going to do x times x squared plus 4x plus 3, that's the other denominator, plus 3 times x squared plus x minus 6, all over x squared plus x minus 6, x squared plus 4x plus 3. And then you distribute all of this, you're going to get a cubic polynomial that is not factorable unless you use the rational root theorem. And I'm telling you, it's just too complicated. And I did it in class, but I don't see a reason to make this video any longer than it really needs to be, okay? Stick with finding the least common denominator with method 2 on the right, because trust me, if you just get a common denominator and you don't bother finding the least common denominator, you can run into some very ugly factoring. Factoring that you might get stuck on because it looks so complicated, all right? It'll still work, but it's not efficient. So you're welcome to try it on your own method 1, and if you want to talk to me about it, you can. But I'm just not going to do it in this video, okay? And there you go. That's what we did in class. I hope the review helped and all that business. So there you go. Okay, enjoy the rest of your day, and I'll see you around.